A polynomial function p is given by p of x equals negative x times the quantity x minus 4 times the quantity x plus 2. What are all intervals on which p of x is greater than or equal to 0? Well, basically what I want to do is I want to find everywhere here where I have a positive function. So this is what I know. This is a cubic, okay? Not only is a cubic, if I were to multiply this all out, the most important part is negative x times x times x is going to give me negative x cubed. Now, a cubic that is graphed that has a positive leading coefficient looks like that. I don't want that. This is a negative leading coefficient, so I'm going to get a cubic that looks like this. Now, I'm going to make over here what's called a sign table. And in my sign table, I'm going to label all of my zeros, which can be found from back in this polynomial. So using the zero product property, I know that one of my zeros is going to be negative x equals 0. So one of my zeros is x. X minus 4 equals 0. So if you add 4, you get 4. And x plus 2 equals 0. So if you subtract 2, you get negative 2. So my zeros are negative 2, 0, and 4. Why is that important? Because this graph is going to cross the x-axis at 3 spaces, negative 2, 0, and 4. So when I graph this, it hits negative 2, comes back up, goes through 0, comes back down, goes through 4. So my graph for everything below negative 2 is positive. My graph for everything between negative 2 and 0 is below, so negative. My graph for everything between 0 and 4 is positive. And my graph for everything after 4 is negative. I care about when my polynomial is positive. So my polynomial is positive for everything less than negative 2. So they want me to use interval notation. So I'm going to say everything less than negative 2. I'm allowed to include 0. So I'm going to say, I wrote down the wrong thing. I'm going to say everything between negative infinity to negative 2, but also including 2. Is that it? Nope. I can include everything in between 0 and 4, so I'm going to include 0, and I'm going to go to 4. Boom. Those are my two intervals, which appears to be D. All right, there you have it. A little sign graph action. The function f is given by f of x equals 9 times 25 to the x power. Which of the following is the equivalent form of f of x? So it's going to make me be a little clever and creative here. What I have, and maybe what is probably going to ask me to do, is I have a 9, which is a square, and a 25, which is a square. And it looks like it kind of wants me to deal with those squares. So if I wanted to, I could write 9 as 3 squared, which none of these give me that option. I could also write 25 as 5 squared to the x, like so. This simplifies to 3 squared. And when you have an equation, or rather an exponent to an exponent, you multiply the exponent. So that's 5. 2 times x is 2x. So I cannot combine these two in any way because the bases are different. So, and also if you're thinking, well, can you like distribute that 2 and kind of include it? Nope, because that's a 2x and that's a 2. We're done here. So anything without the 3 squared is no good. So they just want us to keep it at 9. What they want us to do is make this 5 to the 2x, which leaves me not with C, but with D. Okay, so this is basically saying, hey, are there any ways that you can write this guy out? Yeah, sure, like that. Is it a stupid problem? It sure is. The figure shows the graph of a function f. The 0 and extrema for f are labeled, and the point of inflection of the graph of f is labeled. Oh, I see it. Okay. Let A, B, C, D, and E represent the x-coordinates of these points. Of the following, on which interval is f increasing and the graph of f concave down? So I care about increasing and concave down. Well, let's do this. This is my inflection point that they were talking about. Concave down looks like this. So concave down is going to be this red stuff right here. Concave up looks like this. Not that we are asking for it, but that's concave up. Now, I only want concave down, which means don't care about you. What I also want is not only is it concave down, but increasing. This is concave down, but it's only increasing from that part to that part. Okay, so this is where it is concave down and increasing. This is concave down and decreasing. So what interval is my graph here? Concave down and increasing. Looks like it's between from A to B. And so that gives me the option A. That's my guy. The function f is given by f of x equals 5x to the 6th minus 2x to the 3rd minus 3. Which of the following describes the end behavior of f? All right, well, what we have here is we have ourselves an even degree function, and the leading coefficient is positive. So if it's even and it's positive, whatever happens in the middle, blah, 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 is going to look like that. Okay, so as we approach infinity, negative infinity, it hits positive infinity. As we go to the right, going towards infinity, it also goes towards positive infinity. Now, they want us to use limit notation. So we can say that the limit as x approaches negative infinity, which means I'm looking and I'm tracing to the left. What is this? F of x is going to be positive infinity. My limit as x goes to the left is going way up here, which is positive infinity. So adios, adios. Also, my limit as x approaches positive infinity is going upwards as well, which means it's going to hit positive infinity. So adios and hola, bay. Let x and y be positive constants. Which of the following is the equivalent to 2 ln of x minus 3 ln of y? Now, x and y have to be positive because you can't take the ln of a negative thing. So, first things first, ln's follow the same rules as logs. So whenever you see a number in front of an ln or a log, you can turn that into the exponent here. So that's what I'm going to do. And this becomes ln of x squared minus 3 ln of y cubed. Like that. Now, since we're subtracting here, we can combine the LNs. And when you add, you multiply the insides. In this case, we're subtracting, so we're going to divide the insides. That gives us A. Yeah, ln. The polynomial function p is given by p of x equals x plus 3 times the quantity x squared minus 2x minus 15. Which of the following describes the zeros of p? So before I even look into anything, if I want to find the zeros of p, let's see if I can factor that any further, and we'll set that equal to 0. I have x plus 3. I need to come up with two numbers that add up to negative 2 and multiply out to negative 15 and negative 5 and positive 3 should do the trick. Now what we have here, if I want to go one step further, is we have x plus 3 squared and x minus 5. Okay, so my zeros are going to be negative 3 with a double root, or some people say multiplicity of 2, and then we have positive 5. So I have two real roots where I repeat myself, but I wouldn't actually graph that. It wouldn't look like that. So when I look at this, P has exactly 2 distinct real zeros, that's my correct guy. Okay, P has 3 distinct real zeros, imply that I have 3 zeros and they're all different numbers, and that's not the case here. Okay, I do have 3 factors, but 2 of them repeat, so I only have 2 real zeros. And this is talking about, do I have an I? Do I have complex numbers? No, nothing like that. My answer is A. Make sure you read a problem like this carefully because the temptation to select B is there, but distinct means its own individual and unique number. That's not what we have. In the xy plane, the graph of a rational function f has a vertical asymptote at x equals -5. For what it's worth, vertical asymptotes exist, okay, when you have something like a in the denominator. An a in the denominator would make that disappear. So when I see something like that and it's telling me something about vertical asymptotes at x equals -5, I need the opposite, x plus 5. Now, what we have to be careful of is vertical asymptotes exist as long as the same thing doesn't appear upstairs. If up here I have x minus a and down here I have x minus a, I'm not allowed to use a still because a would make the bottom undefined. It would make the denominator 0. But it creates what's called a hole. So when you graph it, it looks something like this, right? So what I need in this case is I need the vertical asymptote, which means I need the x plus 5 on the bottom and not x plus 5 on the top. Okay, so I have x minus 5 on the bottom, nope. X plus 5 on the bottom, x plus 5 on the top, nope. X minus 5 on the bottom, no. X plus 5 on the bottom, nope. X plus 5 on the bottom, no. X plus 5 on the top, yep. And that's my guy. Let f be the sinusoidal function. There you see a sinusoidal means it's periodic, goes up and down like u. The graph of y equals f of x is given in the xy plane. I see that. What is the period of f? Okay, so the period of f is how many spaces it takes for one complete rotation to go from start to beginning. So the easiest thing to do is go here and start at 0. We go up, we go down, we start over at 4, which means my period is 4. It's as simple as that. It's basically you're going to have something that repeats over and over and over again. How many units left to right does it take for the repetition to take place? And in this case, it goes from 0 to 4, which means the period is 4. The end. The exponential function f is defined by f of x equals ab to the x, so the typical exponential function formula. Where a and b are positive constants, very important, the table gives the values f of x at selected values of x, which of the following statement is true. So usually when I see this, I often think, oh, okay, I need to come up with a formula, and maybe I will. Maybe I will, maybe I will. Now, this is a no calculator section, so I'm not going to pick up a calculator to do this. And if you're wondering, how is this guy going to do it? How is he going to do it? Well, let's find the pattern. Okay, the pattern here gives you our b. And it looks like the way I get from 3/4 to 3/2 to 3 to 6 to 2 is I multiply 2 every time. So what I have is f of x equals some number, a, I don't know it yet, times 2 to the x power. Now, the way I find out what this initial guy is if I were to substitute 0 in for 2, this whole thing would become 1. So common sense would tell me that if I plug in 0, whatever it is times 1 gives me my answer. I got 3/4. So if I do 3/4 here, then when I plug in 0 to x, 3/4 is going to be my answer. Okay, so again, if you're not sure what I did, the way I find my b is what I multiply to get from one number to the next. The way I find my a is what is my f of x value when x is 0. So let's take a look at what we have, because here it's not asking for the formula, it's asking me for facts about the formula. and it wants to know what's going on where I have a positive A, so all of these have a positive A. Makes sense, it has to be if it's going to be increasing. 2 to the x power implies that B is not in between 0 and 1. It is bigger than 1. It's not in between 0 and 1, and it is bigger than 1. Now, is this growth or decay? Well, if this guy is increasing, I think it's going to be growth. Now, it would be decay here if this number is in between 0 and 1. That's not what I have. It's bigger than 2, which means every single time I multiply by 2, I multiply by 2, I multiply by 2. That is exponential growth, and D is my answer. The function f is given by f of x equals x squared plus 1, and the function g is given by g of x equals x minus 3 over x. Which of the following expression is f of g of x? All right, so this is a typical composite problem that you may have seen in Algebra 2 if you got this far. And when you have a composite equation and it says find f of g of x, that means start with f and replace every x with g. So f of g of x, okay, and let's do this. Let me be a little bit more clever with my colors. So f of g of x means I'm going to start out with f and write out a big parentheses for every x I get. So I have x squared plus 1. But instead of x, I'm going to replace x with g of x, which is x minus 3 over x. Now, when you take a fraction and square it, you square the top and you square the bottom. So this becomes x minus 3 squared, a perfect square trinomial, over x plus 1. So taking it one step further, x minus 3 times itself means, you FOIL it out. So I'm going to do that using the shortcut. I've got x squared minus 6x plus 9 over x plus 1. Oh, you know what I forgot? I forgot to square this too. Oh, silly me. That changes a lot. I'm looking over here, looking at my answers, and I'm not seeing anything. And that's because when I squared the top, I forgot to square the bottom. But I did. I remembered. I didn't forget. And that's an acceptable answer. They're not going to make me combine these guys into one big fraction, fortunately. And even if I did, that would just become x squared over x squared. You would become 2x squared. Not too bad. But, yeah, just be careful when you square a fraction. Don't forget to square the top and the bottom like I kind of did. But I recognize it. I recognize my faults. It's important to do as a human. To err as human. The table shows values for a function g at selected values of x. Which of the following claim and explanation statements best fits the data? Okay, so looking at a quick thing, they want us to determine if it's linear or quadratic. If something is linear, that means every time this goes up by the same number and all of these go up by 1, these guys would have to go up by the same number too, and that's what would make it linear. So in order to get from 53 to 78, I add 25. In order to get from 78 to 97, I don't add 25, I add 19. This one I add 13, and this one I add 7. So since I didn't add by the same number every time, it's not linear and it's not linear. Now there's a second test to this before you think about a calculator, because this is not a calculator section. In order to find if it's a quadratic, you repeat the process. Okay? So what we did is we found the rate of change and found that the rate of change was not the same. Okay, but is the rate of change of the rate of change the same? Well, I guess we're about to find out. In order to get from 25 to 19, you subtract 6. In order to get from 19 to 13, you subtract 6. And in order to get from 13 to 7, you subtract 6. So this is a quadratic. Yippee. But why? Because the rate of change over consecutive equal length input values is constant, or because the change in the average rates of change over the consecutive equal length input intervals is constant? That's my guy. Now, I know the wording is very confusing. It is. And when I look at a problem like this, I have to get beyond the wording. What I have here in blue is the rate of change, period. And C is saying that the rate of change is constant. That is not true. D is saying that the change in the average rate of change, which means this is my average rate of change, this change is what's changing. Oh my gosh, so much change, I should be going to an arcade. The answer is D. The function g is given by g of x equals 7 sine 2x. Which of the following is an equivalent form of g of x? Well, immediately I see sine of 2x, which tells me this is a double angle formula. And so there's a little rule that says sine of 2 theta is going to equal 2 sine theta cos theta. So common sense would tell me that 7 sine 2x is going to be 7 times 2 sine x cos x. And 7 times 2 is 14 sine x cos x. They decided to be butt heads and put it backwards here, but it's the same exact thing. Same exact thing. All right, not so bad. You just have to have that memorized. The function g has the property that for each time the input value doubles, the output value is increased by 1. Which of the following could be the graph of y equals g of x in the xy plane? Well, it's not going to be a straight line, that's for sure. When I see a problem like this, I don't know if my graph is going to be exactly the same, but I'm going to try to imitate a graph. So I'm going to start out with 1 because I really can't start out with 0. It says every time the input value doubles, the output value increases by 1. So I really can't start out with 0 because I can't double 0. So I'm going to start out with 1, 1. Every time the input value doubles, so 1 times 2 is 2, it goes up by 1, so not much there. Anytime the input value doubles, it goes up by 1. Anytime it doubles, it goes up by 1. So if I were to make some arbitrary graph, right, where I need to go out 1, 2, 3, 4, 5, 6, 7, 8, and I need to go out 1, 2, 3, 4, like so. I have a point that looks like this. I have a point that looks like this. I have a point that looks like this. And I have a point that looks like this. Perfect. Now, which of these looks like that? You do. It has log vibes to it. Lots of log vibes to it, not exponential vibes. Log vibes. If I knew how to draw, it would be a lot better looking, but, you know, beggars can't be choosers. And math teachers can't be art teachers. A complex number is represented by the point in a complex plane. For what it's worth, complex numbers in the complex plane can be written like that. So that's part 1. The complex number has the rectangular coordinates 3, 3. Which of the following is one way to express the complex number using the polar coordinates r theta? So what I have to do is I have to turn rectangular 3, 3 into polar r theta. Once I have that, I then plug whatever x and whatever y I get into here, and that gives me my answer. So a very roundabout, pain-in-the-butt problem, but, you know, it's AP, so it's got to be a pain. First things first, if you're going from rectangular to polar, you need 2 main things. Thing number 1 is r is going to equal the square root of x squared plus y squared. Some teachers might have r squared equals x squared plus y squared, then you square root it. It's the same exact thing. It's all Pythagoras and stuff like that. Also, I need to know that theta is the inverse tangent of y over x. So let's do some labeling. I have 3, 3. I'll put that over here. And so 3 is an x, and 3 is also a y. Happy day. So my r is going to be the square root of 3 squared plus 3 squared, which is the square root of 9 plus 9, which is the square root of 18. And this is the same thing as 9 times 2. So rip out that 9 and make it 3 root 2. So there's my r. Okay? So that's part 1. We have an r. And my r is going to be 3 root 2, which allows me to eliminate 2 answers, but, we'll get to that. Thing number 2 is I need my theta. Theta is going to be the inverse tangent of y over x, which means the inverse tangent of 3 over 3, which means the inverse tangent of 1. Now, the inverse tangent of 1 is going to be pi over 4. Now, some people might be like, isn't it also something else, like something in the third quadrant? Yes, it is. But since we're given the 0.33, I care about my first quadrant answer only. So there you have it. I have an r, I have a theta, and that almost gets me where I need to be. Now, I can circle my answer and say, yeah, I definitely know it's A. But let's take it one step further just a little bit. Because now I have to take my r and my theta and plug it into that formula-looking thing, okay? We know that if we were to write out all the rules for polar and rectangular, that r, or rather x, is equal to r cos theta. And my y value is going to equal r sine theta. So when I plug all of this in, okay, and make it look like that, x is going to equal r 3 root 2 cos theta, which is pi over 4, plus I r, which is 3 root 2 sine theta, which is pi over 4. So a pretty gross problem, very challenging, probably one of the more challenging problems that we run into. Polar's fun, but a lot of memorization, and in this case, this is a lot of work. But we did it. We did it just fine. Ooh, squint your eyes. The figure shows a circle centered around the origin with an angle of measured theta radians in standard position. The terminal ray of the angle, which means, well, you'll see, intersects the circle at point P, so that's my terminal ray, and point R also lies on the circle right there. The coordinates of P are x, y. The coordinates of R are x negative y, which of the following is true about the sine of theta. So let's label a few things, all right? Your xy, your x negative y. And I care about sine. And when I'm dealing with unit circle, I'm really thinking stuff like sine theta equals y over my radius. Now that comes from the idea of right angle trigonometry, where if I were to take a theta, right, and I could draw this right here. Okay, this is y units long, this is x units long, that's r units long because, that is an x coordinate, that's a y coordinate, r is my radius. And sine comes from so katoa, opposite over hypotenuse. So that's where sine theta equals y over r. In this case, I know what r is. Okay, r is 5. So I could say sine theta, in this case, is y over 5. And so when I look at my options here, the only option that matches that y over 5 is going to be D. Sine theta is y over 5. because if the ratio of the blah, 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 I'm pretending to read it because it's terrible, it's awful, but sine theta is y over 5 due to the fact that we have this, basic trig concept. Sine theta equals y over r. So yeah, I probably overcomplicated it, and maybe this problem overcomplicated it, but don't overcomplicate it. It's not that bad. The function f is given by f of x equals 3x squared plus 2x plus 1. So it's a parabola. The graph of which of the following functions is the image of the graph of f after a vertical dilation of the graph of f by a factor of 2. A vertical dilation represents, if you take something like this, which is a parabola, do you make the same parabola skinny or do you widen it out? That's what it means by vertical dilation. The way you do a vertical dilation is you take whatever scale factor you're using, usually we call scale factors k, and you just multiply it to f of x, right? So in this case, what we're going to be doing is we're going to be multiplying all of f of x by a scale factor of 2. So 2 f of x is the same thing as saying 2 times the whole polynomial. Okay, 3x squared plus 2x plus 1. Okay, distribute that out. You get 6x squared plus 4x plus 2. And that appears to not be u, probably u, not be u, and not be u. So it's going to be b because this is a multiplicative transformation of f that results from multiplying f of x by 2. And that's what we did. Done. The table gives values for the functions f there and g there at selected values of x there. Function f and g are defined for all real numbers, which means that you're allowed to plug in whatever you need. Let h be the function defined by f of g of x. So what is the value of h of 0? All right, well, h of 0, it's supposed to be a 0, equals f of g of 0. Now let me put g of 0 as a different color, and you'll see why in a minute. If I want to find out what g of 0 is, I am replacing x with 0. So g of 0 is 1. So f of g of 0 is f of 1. Done? Nope. Because now what I have to do is I have to find out what f of 1 is, and it's negative 2. So h of 0 ends up being negative 2, and the answer is A. So this is one of those modeling problems, not too much to think about. You just need to know how to read a table and answer accordingly. Done. The function f and g are defined for all real numbers so that g of x equals f of 2 times the quantity x minus 4. We'll talk about that in a second. Which of the following sequences of transformations maps the graph of f to the graph of g in the same xy plane? Now, whenever you have a transformation like this, okay, it's giving us f of 2 times x minus 4 in parentheses. First things first, whenever you see an x minus or an x plus something, that is moving to the left or to the right. Now, since this is x minus 4, you're moving to the right, which seems backwards, but it's backwards inside this parentheses. And I believe that's pretty much the only time you're going to see something like that. So this is moving 4 to the right. That's the easy part, in my opinion. Okay, so 4 to the right, which pretty much gets us our answer right away, but let's continue this problem. If I'm looking at 2 here, 2 is being multiplied to x minus 4. Whenever your number that's attached to x, and 2 will be attached to x, whenever you have a number that's attached to x, if it's bigger than 1, it actually widens your graph out. If it's bigger than 1. Okay? It widens your graph out. So in this case, what I'm going to have is something that widens out and moves to the right 4. And the only thing here, first off, I mean, if I look at the horizontal translation, which is just fancy talk for moving to the left or to the right, this means move left 8, no. Move right 8, no. Move left 4, no. Move right 4, yes. But also here it gives us that horizontal dilation of a half. Now, a vertical dilation is when you take a number and multiply to all of f of x. So this would be a vertical dilation of 2, and I have a problem where I do something exactly like that, but that's not what we're dealing here. When you're talking about horizontal dilation, you're basically looking at this guy that's attached to x itself, and you're taking the reciprocal of it. And in this case, the reciprocal of 2 is a half, and that's why D is our solution. Kind of weird, kind of confusing, because you want to say 2, but when you do say 2, none of these will work. Although, you'll be tempted to think it works because if you just distribute it out, you just got to be careful with this one. Very, very, very tricky stuff. The figure shows the graph of a trigonometric function f. Which of the following could be an expression for f of x? So they say we could use either sine or cosine. So that's issue number 1. So let's do this. Let's set up where we could be, okay? I'm going to write out basically what I consider the general form for a sinusoidal function. So a times trig, which could be, sine or cosine, times b quantity theta minus c, close it, plus d. Now what we're dealing with in all of these is a is your amplitude. Now, before you say amplitude, if you're like, well, from the bottom to the top, it looks like it's 6. Correct, but you want half of the total height. Okay, so our amplitude in this case, which goes from -4 to +2, our total height is 6, which means our A is 3. So we start out by saying that it's going to be 3 times blah, 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 blah. And so far, all of these contain 3, so that didn't help. I'm not going to worry about the trig function, not yet, okay, because I have either sine or cosine, and the last thing I want to do is try to pick one and pick the wrong one. All right, now let's see what b is. Always the trickiest part. B is going to always equal, for something that's sinusoidal like this and dealing with radians, B is always going to be 2 pi divided by your period. Okay, now if I just pick like the tippy top here, boop, to the tippy top here, boop, that is a change of 3 pi over 2 minus 1 pi over 2, which is pi or 2 pi over 2, or pi. So the period is pi. So B is going to be 2 pi over pi, which means B is 2. Cross you out. So looking at these, which one of these has 2 for B? All of them. So that didn't help. Now, I'm not going to do C yet. C has to do with the left or right phase shift. All right. Since I'm not choosing my sine or cosine yet, I don't know my phase shift yet. Okay. So I'm not going to worry about that yet. What I am going to worry about is D. D represents the horizontal phase shift. And in this case, if we're supposed to have everything exactly from -3 to +3, and we don't, and it looks like it's just shifted down 1, where maybe this could be the beginning or something like that, it looks like what we're doing is we're moving everything down 1. So my D is going to be -1. None of you. So far, nothing is helping me. Nothing is helping me at all. So what I have to do is now I have to choose, do I want a sine or a cosine? And let's choose sine, because why not? Okay, let's choose sine because why not? If it was a sine, this is where I would start. Okay, so if it was a sine, I would have sine blah, 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 theta, and then I figured that if it's supposed to start here, that is me moving my graph to the right 2 blocks. So if 4 blocks is half a pi, then 2 blocks is 1/4 of a pi, like so. So x minus 1/4 of a pi. So one of these rules, one of these graphs that I could have is 3 sine, what is that? 2 theta minus pi. So do I have a sine theta minus pi over 4, x minus pi over 4? Yeah, I do. So this guy will work. So I kind of did things the long way. What may not be the worst idea here is if you look at these and notice you're exactly the same, you're exactly the same, you're exactly the same, and the only things that are different are the fact that I have sines, cosines, and horizontal shifts, then it may not be the worst idea to just start from there and see if what you're doing is okay. So if you're like, oh, well, man, this looks like a cosine, but it's a negative cosine, so I don't like that. So, is it a cosine where I move over pi over 2? I don't move over pi over 2 for my cosine, so it can't be any of my cosines. I didn't want to do that. It can't be any of my cosines, and the only sign that works is this one because I'm not shifting over pi over 8. That would have me start here. So very strange problem. This is no calculator, so it's not like you could just plug it into your calculator and see what works out. This is you really knowing how to do phase shifts left to right, and it's definitely not pleasant at all. Let f be a rational function that is graphed in the xy plane. Consider x equals 1 and x equals 7. The polynomial in the numerator of f has a 0 at x equals 1 and does not have a 0 at x equals 7. So let's draw a little rough draft out. It has a 0 at x equals 1, which means there's a factor of x minus 1, and it does not have a 0 at x equals 7, which means I'm not going to have x minus 7 up there. Very good. The polynomial in the denominator of f has zeros at both x equals 1, so x minus 1, and x equals 7, so x minus 7. The multiplicities of the zeros at 1 in the numerator and in the denominator are equal. So however many x minus 1s are up here, literally the same exact amount are down there. So whatever happens, you would cross them out no matter what, if that's what you're supposed to do. But we're probably dealing with holes and vertical asymptotes just by looking at the words. So which of the following statements are true? So I can look at this and easily say that whenever I have a factor up here that's literally the same exact thing down there, that tells me that I have a hole at x equals 1. And if you're like, what about that whole multiplicity things? Well, that means like if I have 3x minus 1s and 3x minus 1s, same exact rules apply. Now, since I have an x minus 7 in the denominator and no x minus 7 in the numerator, that means at x equals 7, I have a vertical asymptote, not a horizontal asymptote, a vertical asymptote. The old VA. So which one of these says holes at 1 and vertical asymptote at 7? Holes at both? Nope. Vertical asymptote at 1 and a hole at 7? Nope. Graph of x has a hole at 1 and a vertical asymptote at 7? Yerp. And the graph of f has a vertical asymptote at both? Nope. Okay? So one of those makes you think about where a vertical asymptote and a hole comes from. The AP Precalculus Practice Test that I've been seeing, they love these problems. The increasing function p gives the number of followers in thousands for a new musical group on a social media site. The table gives values of p of t for selected values of t in months since the musical group created their account on the social media site. So in other words, when they opened up the site, they already had 20,000 followers. And then a month later, they have 30. And then a month after that, they have 45,000, so on and so on. Since the musical group created their account on the social media site, I already read that. If a model is constructed to represent these dates, which of the following best applies to this situation? So these go up by 1. I'm not going to overthink that. What I'm going to do is I'm going to rewrite the P of t values down here, and I'm going to try to find a pattern. Like so. All right. Let's see what it takes to get from one number to the next. Add 10, add 15, so we can see already that it's not linear. Add 22.5, add, I don't know. Now let's see what the next pattern is. Okay, so it's not linear. Let's see if it's quadratic. Add 5, add 7.5, add definitely not 7.5 again, so it's neither linear nor quadratic. Okay, so we can get rid of the linear options because they're gone. Now, I didn't even have to bother doing the quadratic. I just did it not looking at my answers ahead of time. Shame on me. Now, what I do have is I have an exponential function. What you need to understand about an exponential function is exponential functions look like this. The most important part being that b right there. That b tells you what you multiply every time to get from one number to the next. So I'm either going to multiply 20 by 2/3 to get 30, or I'm going to multiply 20 by 3/2 to get 30. Well, if I multiply 20 by 2/3, I'm actually getting a smaller number because this guy here represents exponential decay. Remember, if your b is in between 0 and 1, it's exponential decay. So the only one that makes sense here is d because this represents exponential growth. So all of the numbers that I just kind of threw out at you, kind of pointless. All right, but the reality is 20 times 3/2 is going to be 30, and 30 times 3/2 is going to be 45, and so on and so forth. And then from there, if you really wanted to build on that 20 based off of the 0, you're in good shape. But the only one that makes sense for this one is D, because we first found out it couldn't be linear, doesn't follow a pattern right away, therefore it must be exponential. This one means it's going down, this one means it's going up, so I have to choose the one that's going up. That's it. Ooh, a free response for AP Precalculus. This would be considered a first problem in the first part of your free response section. The reason why is you are allowed to use a graphing calculator, and it deals specifically with modeling and stuff like that. You're not looking into real life. Let's find the sinusoidal function of this oscillating fan. You're not looking at stuff like this. Okay, so we are allowed to use a graphing calculator for this. So every now and then you'll see me throw up a picture of what we're dealing with here and there while we do this problem. But, I'll do as much as I can without a calculator. All right, so I'm going to do A on this slide and then move on to the next slide and the next slide. So you will see A, B disappear as I move on. Just make sure you rewind if you have to understand everything. Let f be an increasing function defined by x has to be positive. The table gives values of f at selected values of x. The function g is given by g of x equals this polynomial x cubed minus 14x minus 27 over x plus 2. The function h is defined by h of x equals, I hate that, g of f of x. Find the value of h of 5 as the decimal approximation or indicate that it is not a decimal. So A, problem 1. Let's find out what h of 5 is. Well, h of 5 is the same thing as g of f of x. So g of f of 5, and let me bring my color blue back. So f of 5, according to this picture up here, f of 5 is going to be 34. So now I need to find out what g of 34 is. Okay, so h of 5 is the same thing as g of 34. Remember when you do these free responses to make sure that everything that you're doing flows and it looks nice and clean. Now, you don't have to show your work here. But what you would want to do is throw that in a graphing calculator, okay, whether you type it all out or you graph this function and use your table to scroll down and find out what g of 34 is. But g of 34, when typed out, when calculated, is going to be 1077.806. Remember to always use 3 decimal places for AP Precalc. That's what they're looking for, 3 decimal places. So that's A, part 1. Okay? A, part 2. Find the value of f inverse of 4 or indicate that is not defined. Well, this is defined because it's continuous, so that's kind of important. You don't need to say that, but that's kind of important. Thing number 2 is, remember, an inverse is when you take your x equals y and swap them. So in a sense, f inverse is basically you saying, I want f of y, and I need to find my x. So if your y is 4, let's go to where I get 4, and when I get an answer of 4, it must mean I plugged in 3. So f inverse of 4 is 3. And some people might not look at it that way. Some people might be like, well, I just found out that f of 3 is 4, which means flip them. F inverse of 4 is 3. Yeah, that's fine. Just make sure when you write out your answers on free response problems like this that you write out your answers. Don't just circle 3 because they may not give you credit. I don't know. This is a new course. So we're all kind of figuring this stuff out as we go along. So there's your A. Okay, ugly number, not so ugly number. Let's move on to the next thing and do B. Okay, same exact problem doing B now. Find all the values of x as decimal approximations for which g of x equals 3. So here's g of x. There's g of x right there. I'm going to write out 3 equals, and this is, let me write it out that this is B1. 3 equals x cubed minus 14x minus 27 over x plus 2. Now, this is what I would do. Okay, this is what I would do. What I would do is I would go to a regular old graphing calculator. And again, I will put up a picture of what it looks like on a graphing calculator or on your graph. But if you're using like a TI calculator, type in one of your calculators, 3. Type in the other equation in your calculator, x to the third minus 14x minus 27 divided by x, that's supposed to be divided by x plus 2. And when you graph both of them, you will see like a parabola looking thing kind of crossing the number 3. What you need to find there is intersect. So you go to calc, you go to intersect, enter, enter, enter. And when you do that, you have an x value at 4.875. Again, 3 decimal places. 3 decimal places. And so what I'll do is I'll quick freeze myself and show a picture on the screen of what you should do to do that on your graphing calculator. But yeah, that's how it's done. Do B2. Determine the end behavior of G as X decreases without bound. All right. Wording, be careful. Express your answer using the mathematical notation of a limit. Let me quick throw up what the graph looks like again. Now, what you can see is you have yourselves what looks like a parabola, which makes sense because if you were to if you were to kind of do the x cubed over x, that becomes quadratic-ish. The problem is we, have horizontal asymptotes that make things look bad. But what we have is a quadratic kind of with a positive leading coefficient. So we know it's going to have this type of behavior. Now, what the question is asking is determine the end behavior as g of g as x decreases without bound. That's a fancy way of saying find the limit as x approaches negative infinity. What does my picture look like as I move to the left? And as I move to the left, my limit as x approaches negative infinity. Don't know why I put my arrow that way. My limit as x approaches negative infinity of g of x is going to be positive infinity. Now make sure you write this out in limit notation because that's what they want. I know I saw this problem before and I was thinking, let's write both of them. The limit as x approaches positive infinity is also infinity. And you could say that. And they shouldn't mark you wrong because you're just giving too much information. You just never want to give more than necessary because if what you give that's more than necessary is incorrect, they will mark you wrong. So that's B. Dunzo. Let's move on to C. All right, use the table of values of f to determine if f is best modeled by a linear, quadratic, exponential, or a log function. All right, so the top goes up by 1. Great. Let's see what happens here. Boom, 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 boom. So I go from negative 10 to negative 5 is you add 5. Negative 5 to 4 is 9, so it's not linear. 4 to 17 is 13, and 17 to 34 is 17. All right, so it's not linear because when I do the rate of change, the rate of change is different every time. Let's see if it's quadratic. Let me get a better color. That seems to block that. Wish I got more space on this one, but what are you going to do? To go from 5 to 4, you get 4. To go from 9 to 13 is 4. To go from 13 to 17 is 4. So since this is considered the change of the rate of change, since the change of the rate of change, or the second level of changes, since that is equal, we could say for C part 1 that this is quadratic. Because when we tried linear, we didn't get the same number every time. But when we did another level, the change of the rate of change, we got 4s each, which tells me it's quadratic. C2. That's all we had to do, no explanation. 2 is the explanation. Give a reason for your answer based on the relationship between the change of the output values of f and the change of the input values of f. What I saw is the rate of change is 4, therefore f of x is quadratic. I don't know if I'd have the space there. Okay? And I think that description is good enough. I mean, give a reason for your answer based on the relationship between the change of the output values. So the change of the output values and the input values, the rate of change is 4. Okay, therefore f of x is quadratic. So that would be an example of the very first free response problem you would see on the pre-calculus AP exam according to Collegeboard. Very exciting. Very exciting. Not too bad, but not too easy either. So, good luck. Love you. Like and subscribe.